Hello everyone. I Today I'm gonna explain this program I built. It's a Python console car game program. Uh, and here it is. This is a program, and when you run it, it will be something like this. This is start up screen. After that, you can play the car. Use the keyboard to move the car left and right, and to avoid to hit the curbs or the docks. If you hit the docks, it's gonna crash, and then it will start over again. Okay, that is the program, and I'm gonna stop it. So you will see this is the the program. Here, this is a very small program, and with the something like 170 lines of statements, and there are several functions there. Let me count: 1, 2, 3, 4, 5, 6, 7. Okay, 7 functions, and actually, anyway, it's a very simple program. I will explain how it works. And actually, this is a program actually prepared for my students in the class of Camp 1012. So to help them to review the concepts we have taught in a class. So it's supposed to be very simple. So for that reason, actually split them in 4 days. You will see here the day 1, day 2, and day 4, because they're just beginners. I think it would take them more effort to learn this program, so I split them into 4 days. Actually, I just spent something like 1 hour or 2 to prepare this program. So here in this video, I'm gonna start from scratch, and let's start a new file here, and I just want to pass them there. Okay. Okay, sorry. I'm not actually start anew. And let me just save it to somewhere. Let's see. Test Python. And I'm gonna switch it to Python. It's here already in Python. So you see here right now we got nothing there. Let's start to build that game. At the very beginning, you need to print the road and the curbs as well. But before that, make sure you're familiar with those statements, expressions, and data structures. For example, for print is a function to print out the strings, and this multiplication can be used for a string as well, which actually will duplicate a string for a specified number of times. For example, we do this by multiplied by 3, and this string AB will be duplicated for 3 times. In that case, you have AB, AB, AB string, a new string there. So also string can be joined or connected using the plus operator like this, and also for this can be used to generate a list collection Also, it can be used for strings or integers. We will introduce it later. And also, important thing about list is the list comprehension. You can use a for loop to generate a list like this. For example, I put a for loop. This will be repeated for 5 times, and which will give you numbers in a range of 0 to 4. And after this list comprehension, you will get a list like this. And also, there are some functions we need to use. CHR converts ASCII code to the corresponding characters, and the ORD returns the ASCII, doing the right in the reverse way, returns the ASCII code of a character. For example, the CHR A here is a character A, so gives a number of 65, which is the ASCII code corresponding to the character capital A here. And ORD, by given this ASCII code, will convert it back to A. I'm sorry, there's a typo. There's no. We should remove this lowercase a. It's just the A. Sorry, this is a typo. I'm gonna remove it later, because right now it's in PDF rather in the PowerPoint, which I can modify. Join is a function which can help you to join the characters from a list like this. I got a list here with 3 components, A, B, C, and with the join, we can get a string ABC by join them together. So this is pretty much like everything you need to know, and let's get it started. So first of all, let's try this. Here we're going to repeat for 10 times, and in each loop or iteration we're going to print out something like this. So here let me do it. Range 10, then we can print a string. And also some other space, and ending with this again, and let's modify that a little bit because we want it slightly different from the last row. And let's see what we're gonna have. See here, we actually got some curves at each side and also in between. This is a road, a track for the car. Okay, so what we're doing here is, let's see, by using this a string, actually create a pattern looks like a curve, and the, this here is the left curve, and this on the right will give us a right curve, and in between them there I just use the multiplication to repeat the space for 45 times. So that's the reason we have the road here. Okay, but putting everything together, you will see the curve. Actually, every curve takes 3 by 20 characters on the screen, while the road takes 45 by 20 there. Okay, we can use, this is pretty much like what you have seen at the beginning. It's what we will use for playing a game. It's the same we're going to use for playing a game. And this looks good, right? But the problem here is even we could have that same or background or curves and road printed out. However, we have to update the content in the scene all the time because we're going to move the car. We're going to have the dogs there printed, and we need to change their positions in the scene all the time. But the print, if you use Python, you know the print function will always print the strings line by line or row by row. It's not easy to make it update at there or refresh the same. So we need a better way to save the content and print the content. So let's check out this thing. By putting everything together, the thing is 51 by 20 character array. And this is curve and roads. If I break them down, so the idea is we can actually rather than print a fixed number of the characters like this and a fixed number of spaces like in previous example, we can use the integer to save them into an array. In our case, we're using a list, like what's happening here in the first row of that line. We're using this to store the value of this character as an array, and then when we need to print them out, we can just convert those ASCII codes into characters, and then we print out them to the screen. So this will allow us to update the values all the time. In case we need to change the objects in the scene, we just have to modify the numbers in the list. This will be much easier. The reason we're using integer is integer can be modified in place rather than the strings. The string is sometimes it's such a headache. If you're familiar with the string, you know the deep copy, shallow copy stuff. It's such a headache. Okay, I don't want. Anyway, the integers takes less efforts than the strings, so that's the reason we're saving. The results are the same with integers. Okay, and here let me give you more info, more details like this. Actually, when you break down the scene into characters like those showing in this grade, we can in each block it's actually a character, and in our case at the very beginning there's nothing in the scene, there are all spaces. In that case we have 51 by 20 space array there, but we can use a list with 20 rows. That's the reason we have a set of lists in the list of 20 rows, where each rows is corresponding to one row here. So this is the first row, the second row, and inside each of the row, and here are characters at the corresponding blocks there. So at the very beginning they're just space, and as I mentioned, I'm using integer to save the value. That's the reason I'm using the ORD to convert character to an integer. So this is the initial setting. And how can we put the curves into the background, into the scene? We just have to update those blocks at the left and right side. However, we need a coordinate system starting from here. The top left color will be 0, 0, which stands for the 0 row and the 0 column. And when it goes over into the scene, we just have to change and that coordinates. So in that case, we can update the objects in taking the curves as an example. We can prepare a curve here, and we update it at 0, 0 position. So this left curve will be put into the scene. I mean, the integers corresponding to the curves will be updated in the list, and later when we print it out, we will see it after we converting them into strings to print it out. And similarly, we can change the place to insert the curve for the left, for the right curve there. So we will see the curves. Okay, that's pretty much like it. Let me modify that program. In that case, we're going to modify it. I actually prepare the files there already. Here's the for day 1 to save your time and my effort as well. Let me just copy them and to here. I'm just gonna put those into comments so you can compare them. You will see here, instead of using the fixed character, we're using integers here. Here is actually the list, using the list comprehension, and you will see actually I just generate a list with 20 sublists inside it, and every one of those lists corresponding to one row in the scene. And for curves, I just prepare one curve. You will see here, because the left and right curve is just the same, and the only difference is they're at different positions. So this are already prepared, like showing here. And to put an object into the scene, we can do something like this. Let me just copy the code to here. You will see here, this function copies an object into the background, into the scene, by putting the object at the position X and Y, or you prefer the row and column, and this is the row number, this is column number. You should put the object, and this is quite simple. You will see here, first of all, we need to figure out the width and height of the scene and object as well. Then for each of the row of the object and each of the column in the object, and that means for every character in the object, we can copy them into the same list like this. First of all, because we're going to put that object in the scene, we need to calculate the target X and Y in the scene. So here is it, and this is just very simple math, and just it's gonna skip the details. And anyway, there are but every time we here, this if is trying to figure out if it's a space or not. Actually, we should put something like this. If it's a space, that means at the certain position the object with nothing to print. So or the target position is it's just not inside that scene or inside that background. So we just have to skip that character. Or it's in the scene and it's a valid character, we just copy them to the target position like this. So we updated the integer in the background in this way. This is a function, and this can be used not only for putting the curves into the scene, and in the future you will see we'll use it for put objects into the scene as well. So the function is prepared, and then we can put the curve in the scene. This is quite easy, and we can do it. Let me copy them to here. You will see we first of all we got a copy of the background, the scene. That's the one we generated. We don't use it directly because later we want to refresh the scene, a background. We can just copy, get another copy. We don't have. In that case, the objects inside that scene will be removed, so we can update the content. We don't. Otherwise, the old content is gonna be occlude with the new content. So that's the reason we're getting a copy of it rather than use it directly. So for the first curve, we're just going to put them at a 0 row, 0 column position. And this is for the right curve, we're putting it here, different places. If you calculate it, you will know it's just right down the right of that scene. So after these two, we are going to update the array. So let me just run it. You got nothing because we haven't printed out anything. So let me just print the updated list and see. You will see, okay, it's updated. You will see that actually the 32 is corresponding to the character space, so that's the reason we got a lot of 32 here. It's corresponding to the space, and the first 3 is the value, the ASCII code for those 3 characters actually. So you will see this is first row, and then in the second row it just repeat that pattern. The only diff and this is not the third. This is the second actually. So the second row is with a space in between, so that's the reason it's 124, and in between it's 32. Okay, meaning that has been printed out successfully. However, those are just numbers. We need to convert the numbers, the integers, into character before we can print them out. In that case, we need another function, which I put it here. Sorry. Let me just send it back. So we put objects and put the curves into the scene, and we have to display it. So in that case, we are converting the integers into the characters, so we can print them out as a string. In that case, we need the CHR function to convert an integer into a character. The CHR function, we're going to use them as a loop. So in that case, I'm just copy this function back to here, and then okay, you will see that this is very simple function which joins the numbers. First of all, I'm using the list comprehension here to generate from the integers as a list of character, because I'm using the chr function to convert each integer as a character. Then we can use the join function to connect this character together as a string. Then for each row we got a string, then we print out of that string. This is very simple. And let's just try to print this same out, because we already have the curves there. Let's see if it worked. Okay, see, it worked. This is the first row, and this is the second row, and so on and so forth. And you can see the integer here. This is the last row. Actually, it's corresponding to this position. So there is a space in between, so it's corresponding to here, 32. Okay, that is, it worked as we have seen. Okay, let's try put more stuff there. Here is another problem. Is let's see, if we want to put a logo like this, we have to convert the string into a list of codes. Actually prepare another file for you. You can write it by yourself. It's something like this. First we have a pattern. Here there are characters. However, because we're saving character as integers in the list, we have to convert them into the list of lists. For that reason, I'm using this function. It's write one function like this. By run this function, it's going to convert this character pattern into list. So after the converting, I can actually copy that into let's just, this is for the logo, so I'm just gonna because I got it, you see here I got a lot of other patterns here. I'm using the same way to convert them into a list. So by calling this function, I'm going to have a list. Let me just run it, see what happened. So you will see that we're actually convert the pattern into a list of integers. So I'm just gonna copy this to here, because it's a sorry, this is what we should have. So let me just use it as a start logo, and just paste that content back to here. You will see we got a list, and this is actually a list corresponding to the logo. Okay, so as long as we have that logo, and we can put them into the same. So let me just fold it to make it easier to for you. So with that logo, we can call the same function as we have used for the curves. Okay, because the logo itself, it's the logo itself is an object, so I can put the function because I'm not using the code, so I need to change the name of the variable here a little bit. So this is it. See here, I'm actually copying the curve, the same with the curve here. For the same reason, because we're going to use the the same with the curves a lot of times, so I'm using a deep copy to get a copy of it, and then I put the logo inside it, and then after that we can print the same out. Oh, okay, sorry, let's print the same out. Okay. So right now the logo will be updated into that same with the curves, and let's see if it works. If it works, you will see. Oh, it works. Actually, this part actually was printed out because of this statement, and after that, we're gonna have the one with a log inside it. So that's it. It's just great. Okay. I also updated those slides to my GitHub, and you can check it out later there. And that's it. And also you can actually put a lot of like the car and dogs there with the same way as I just demonstrated using that function. So in that case, you're going to have dogs and a lot of other stuff there. Let me just copy those dogs in there, and cars and dogs, and also we can put the dogs. Here's the code to put them into the same. You see here, I put the car there and put the dogs there. So here you could see I'm using another copy of that same with curves, because we don't want the logos when we're printing out the dogs and cars in the same. So let's see what it is. Okay, you'll see here it was printed out as dogs and cars there as well. Okay, it worked very well. And also for those you're interested in my GitHub, and you can have it here. And the one is a Python console car game, and I have all the files shared there. So here is the address. Okay, this is pretty much like the content for day one, and let's take a break here. Okay, let's just continue to build our car game for day two. In day one, we actually really have all the objects and the same curves printed. We've already prepared the list of integers for saved contents, and also the function to put the objects in. It's almost there. It's pretty much like all the stuff we need. However, right now the objects are all static. They are still there. They don't move. So day two, the purpose of day two is to keep them moving. In that case, we're going to introduce how to generate animations there. Yeah, we need to make them move. So let me just open a file for day two to make this easier. This is day two. So this is day what we have day one. You can because if you have gone through what we have introduced for day one, these are the code you should have. We will modify based on what we have in the day day one, rather than just copy this whole program there. So let's keep working there on day one and code there. So to make things move in the scene, the only thing we have to do is just update the position of objects in the scene. That's very easy because we have already have the put object function prepared, which allow us to change the coordinates or position of object in the scene easily. We just have to change the parameter of this to there. So different objects will change their position in the scene, like the car, the dogs are in different positions in the scene as we have shown before. So this is really easy. So let's see, but let's put the car into the scene first. Let's fix the car. The initial position of the car is the 50th row, at the 50th row and 4. And I just this is wrong. I just fix its position as the 50th row, but every time when I hit the key, I need it to move by one character. This is a typo as well. One character instead of 4. Sorry for that. So it's a typo, but for those familiar with the print, you see here every time we're printing some out, there it just this is output from the screen the first time. However, when we print out the new thing there, it wouldn't update it in place up here. Rather, it was started as a kind of new rows to print the new content. But it's not animation. We need things to be updated in place. We don't need new rows when we're updating the scene. Otherwise, it's not animation. So we need a helper function, which what we're going to do is after we print out a scene, before we print the next scene, we're going to go back to we're going to clean it back up to here. Then from here we print the new scene. So the helper function is to help us to clean that screen. So let's see what it is. And that's the function, very simple. Here it's actually every time when you're calling those print, it's print out a cleaner. It's a cleaner line of code, so it will help you to clean that let me just copy because it's quite simple function. Let me just copy them to here. Let's see, we have a new function which will help us to clean the content on the screen. So to help you to understand what happens, let me just make the scene stay there for something like 3 seconds. We haven't imported time yet, so let me just import time. So that means we are going to print out those stuff scene by scene first, then I will call this function to clean the screen. That means the last scene with dogs and cars, and you will see what happened. You see, all printed out. After 3 seconds, the scene has been cleaned. You see what happened? Let me do it again. So print it out, 3 seconds, clean the screen. Okay, so it's back to there. In this case, after it has been cleaned up, I can print the new content there. So this is what happening. This is what the helper function is doing. So with that function, we can repeat print out the cars at different position. So in that case, I'm creating a new set of codes. Here you could see I have initial position of the car at the 15th row and the 4th column in the same. And also I set the car speed at 0 and 1, and you can actually modify this one as you wish at any of the speed. And then I use a loop. Every time when the loop is started, I clean the scene, I clean the screen, then I'm gonna put the car, calculate the position, a new position of the car by using the speed values to update the position of the car. Actually, I'm just gonna, this will allow me every time I move the car to the right, one character every time at each tick. So then the car's position is updated, and I put the car into that scene again every time to have a new list of integers. That's new scene representing the new scene. Then I print it out. You will see the car is moving, and for every tick we're using 0.1 seconds there. So this is what's happening, and let me just copy that. Okay, so okay, this has been updated. Maybe we have to write it by ourselves, and so in that case, let me just copy this back to there. Maybe I have to comment out those dogs there. Just we will keep the start screen after start. The logo has been printed out. We will keep this because it will let the logo stay there for 3 seconds. And then I have to comment this out because we're going to do it in a loop. In that case, we will start a while. This is actually the main logic of that game. So every time, as I mentioned, when we started, we have to clean the screen, or clean the scene as well. Then we will calculate a new position for the car. That is, which means the car position. We have to update it. The first one as because this is speed for every tick. I'm just gonna do it like this, and also we can do the same for the second parameter. Actually, it tells us the column, the position column. So the car position has been updated. Then we can put let me just slightly modify this to put the car in. So, and because right now we have a position like this, and this is a row, this is a column. So column actually corresponding to X, and row corresponding to 0. So because the function was declared with X and Y, so like you have seen here, that's X and Y, and so we have to do it this way. So after that, this scene will be updated, and then we can print the content out. Let's print the content out, and then we have to sleep for 0.1 seconds, and so otherwise, if you don't sleep there at each iteration or each run, it's the animation, it's just gonna go too fast. You can't see what happened. You can't see it just finished. Let's see. Okay, stay for 3 seconds. Oh, sorry. What's wrong? Oh, we're printing out the integer directly rather than we're printing out the string. So that's the reason we got this. Yeah, let me do it again. Let me run it again. Start up with local, and you see the car is moving right now. Okay, so it's a lot of fun, right? Let me do it again. Stay there for 3 seconds, and the car is moving. Okay, great. So this is pretty much like how to move the car, and also this is how to move the car, and but at the same time, because the car it just moves by itself, it doesn't like a game. In a game, we usually are able to control the car, so we need when we hit the press the key left and right, it will move to the left or right by 1 character every time. So we in that case we can control the car, and to do this we need help of another library called pynput. This is a library. Actually, you have to install it. It's not installed by default. The way I'm installing it usually are, let me write down some of the code. Usually what when I'm install that, I will use this command in the command line or in the terminal. I'm just typing in the VS Code. It's just for your reference. It doesn't mean when you run it in VS Code it can be executed. You have to do it outside of VS Code. So what I'm gonna do is using the pip to install it, pynput. So this is a way, the command I'm using to install that library. So after that has been installed, it can be used. Let me just comment out this because it's not a legal statement for Python. And then after assume we have already have that library installed, so we can import them here, and we can import that here, and so because we need to call it before the while, so and insert them into here. After that, we need to write a function, and here it is, to tell the program how to control the car. You will see here, this function determines what to do when user press the key. You will see here when the key user press the right key, we will update the car's position towards right by increase by 1 character. Very similarly, when the user is pressing left, we will move it to the left by 1 character using this. Every time we're just updating the position, because after the position has been updated there, and you're gonna see the car is updated in the scene. In that case, we have to comment out this one because right now we need to control the car rather than let it moves automatically by itself. And also you have to put a listener for keyboard here, and we're just this means we're listening the keyboard with the listener, and once the key has been pressed, it will call this function we prepared to change the position of the car. So let's see if it works. Run again. Stay there for 3 seconds. Oh, here's the car. The car doesn't move. Let me press the key. Okay, move to the right, move to the left, to the right again, to the left. Yeah. Okay. So you see here we can control the car. Okay, let me just stop it. Okay, here's a code. As I have explained, I have a function determines what to do when the user presses the key. And also I got the listener started at the very beginning before the while loop. Then we can control the car. And we slightly modify that code, and so we can print the content out. Okay, that's pretty much like what we have to do to make the animation for day 2. Let's take a break again. Okay, welcome back. Let's continue for day 3. In that case, I will close those for day 2 and open up the file for day 3. Those are the code, and we will continue on the code we have for day 2 there. So for day 3, we're just gonna put docs in the scene. So the game, as I mentioned at the very beginning, is about moving the car left or right to avoid hitting on the docks or curbs. So in that case, we have to decide, we have to verify every time when we're updating the objects that if the car is hitting on the curbs or the docks. So this can be so first of all, let's just put the docks into the scene first, because we don't have the docks yet. The idea is we're just gonna generate a dock on top of the scene and let it move downwards with the speed. So every time we just have to update its position, namely the row number of each of the dock. So to start, we have to make this random. So for the column number of the docks, we just use a random function to generate it, and that it is. So let me just comment some the useless code there. We don't need to print out the curbs at the very beginning. It's just kind of misleading. Let me just comment them out a bit. We need the logo. It's a startup screen, and we need the car before we write that for docs. Let me just test if it works. Okay, it just works. Okay, let me stop it. Then go back to the slides. We need to generate docs, and however we have 2 types of docs there. So I'm writing something which allow us to generate a doc by picking up one from the list. In that case, we need a random function as well. So let me just put it here. So we have 2 docs there. We put them into a list, and when I generate a doc, I random pick one from those 2 codes. And also every time we need to recall the docs in the scene. Right now, to make it simpler, I just put the maximum number of docs as 1. That means every time we just have 1 docs in the scene. And also at the same time, we need the speed for docs. To make it easier, just put 1 every time this is for row, so every time it just increase its row number by 1 as a speed. And then after that, we can update docs. This one is the most complex function of this program, and let me explain what happened. I'm just gonna put find out update docs function and copy them back to there, because in that case I don't have to type it again. There are just too many stuff to save my time, my effort, and save your time. Okay, here is how I update the docs. Every time I will update the docs by checking if we should add more docs there. First of all, if I have to check if the doc is already run out from the scene by checking its coordinates. If it's run out of the scene, that means its row number exceeds the scene height there. So I have to remove that docs. So here is for checking which docs should be removed, because we have a list of docs there. So once I found the doc already out of the scene, I will mark it down with those lists by append the information to list. Then I use another loop to remove it from the list of docs there. So from here to here is just the code to remove the docs. Those are remove docs. From here to here, I'm just trying to generate a new doc if there is no docs in the scene. To generate docs, and actually to generate a new doc. And right now we only have one doc. To generate docs, and we have to set an initial position. No, sorry, it's too early for that. We actually generate the doc by chance. That means we don't have to generate the doc all the time. I generate it with a probability of 30%. So this is the way of doing that. I will not explain this. It's just a random function, because the random function generates a number between 0 and 100. And so in case it's less than 30, that's making this condition holds with a probability of 30%. There are some mathematics, but you don't have to know the details. Just know that this will put this generation by chance rather than generate doc all the time. The actual code for generating docs is here. Every time you see here, I use a random function to pick up from the doc type list. It's here because we're generating a random value with either 0 or 1, so it just randomly will pick one doc here as a doc to generate. Then we have to determine the width and height of that doc. That will be used here. And then we initialize the position of the doc like this, because as I mentioned, it should be put in between the two curves there. Yeah, that's it. We're actually generate the initial position like this. And so we don't want it hurt the curves, so I actually increase its column number a little bit, and also anyway I modify the range of the column number of the as the initial position of the dog in this way, and also I will generate it as the 0 row. That means the first row of that scene. After the generation, I can put the dogs. I can put them into the dog list. So this is for generating new dogs. After the generating dogs, and the last thing we have to do is to put dogs into the scene. And this is what this loop is doing. For every dog in the list, we call the put object function, which will put the dogs into that scene to the corresponding position. Because we actually, when we add the dog into that list, we record it beside the code of that dog, and also the initial position of that dog as well. So this will update the dogs. We'll put all the dogs into the scene. Okay, a little bit complicated, this function, but if you split or divide it into 3 parts, that's easier to understand. Especially I put a lot some comments here for you. Okay, we have then actually we have to update the dogs first before we put the car in. So in that case, we have to change this a little bit. This code actually updates the dogs first. After we have the car, but it's okay because we're still in the day 3. Okay, this is for updating it. The dogs are in, and the cars are in, and let's just run it. See, start up screen. This one is not the same width. The reason is actually because previously we're just putting the same width and the height as a fixed number. This is what we put here. So later I decided to use a variable to do it, because in the future, if we're going to change, if we want to change it, it will make it much easier. So that's the reason that one is not defined, but it's okay, and let's define it here. Let's see. Okay, the curves is missing there. That's okay. The reason is not this one. It should be 2. Otherwise, you will see something like some parts of the curve is missing from there. Okay. Looks good. But because we don't have the collision, we don't have the statements for collision, so it's okay right now. You just hit the curbs or the dogs, it's okay. Now we will add that part in day 4 later. Okay, let me just stop it. Okay, that's a code for update the dogs and also put the dogs into the scene. Okay, let's take a break again. Okay, welcome back. Let's continue to day 4. As I mentioned in the content for day 3, that there is no collision, function for that. So here we're going to add that part. Actually, to we just have to change that a little bit when we're putting the objects in, because in that case we have to modify a little bit the put object function there. And here is what I have modified just a little bit. So you will see here the idea is when the target position in the scene we're trying to update is with a value not 32. That means there's really something into the scene. So if we're trying to put the car into that position, the car will hit on that existing object, no matter it's curbs or dogs. So that's very easy. We can just modify that a little bit to make that happen. So and at the same time, because we're gonna use this function for curbs and dogs, we don't care about if it's hitting something. So it's better to add something, a Boolean value to indicate if we are hitting something. So when we're calling that for dogs and curbs, we can ignore that result. But when we're calling the dogs, when we're putting the car, when we're putting the car into the scene, we can check this crash variable returned by this function. Then we will know if the car is hitting something. Here is the object function, and what we're gonna do is just when we started, we can use crashed, or we can just use hit something as a force. And so before here we could check before we should do it before updating something. Let's check if it's equal to a space. If it's not a space, means there are something already in the scene. So in that case, we should hit something as true. And after when we're returning something, we will return this result as well. So it's pretty much like it, what we're gonna use. Okay, function updated, but at the same time, because this has been updated, so we have to in that case we have to update the color function as well. So let's see where we call here, we call it, and so we have to make it a little bit, because we are returning different kinds of things. It's H, that's the reason. Let's see where we have called it. Okay, it's something. Let's see where it has been called. We can ignore those because we don't need them anymore. And it comes to here inside this function. We actually are updating docs, and where the put object has been called. Okay, and the last one here is when we're putting the car into there, we need to know if it's hitting something or not. And another change we have to make is we by doing this we need to put the docs in first, and we need to put the docs in first, and we have to change this as well, and after that we pass this scene. We use this scene for updating the position of the car. So and after that we're able to update the docs first and then the car. And in case it's hitting something, and let's just break this loop first, and let's see, after it's break, let's print out something like game over. Let's see, okay, see if it works. Okay, it's moving. Let me just hit on the dot. Okay, you see here, it's you see a game over here. Okay, that means the collision checking worked. And this is the one we are updating the color function. However, it's nice. However, we want to play that game for multiple times, rather than we just stop, just game over there, stop there. So in case we want to do that, every time when we crash, we will make the screen, we will display a crash sign to the user, and let the sign stay there for 2 seconds and then reset the game. In that case, we need the function to reset the game. Let me copy that function to here. Reset game. Let me just add it to here. No, this is what reset is doing. It's actually set clean the docs and at the same time reset the position of the car. And after that, we have to update the while loop a little bit, and in that case we need the logo. We need a logo as well. Let me just copy that. We need a sign, the stop, the crash sign. It's here, the code. It was prepared in the same way I have introduced before, and this is a crash sign. Let me follow it to make it easier. So we got a sign, then we have to display the crash, the sign, every time when the car is hitting on the docks or the curbs. And then in that case we have to, let me just comment out this break, because we'll need to break the game. And okay, doesn't seem good, so the reason is indentation is wrong. Let me just adjust indentation to make it the same as what we have here. Okay, okay, has been updated. You know, there is a code to display the crash, the sign. And also after that, I will have the game stayed for 2 seconds, then reset the game with continue rather than break the game. Let me slow the game a little bit. Slow down it. Let's check it out. Okay, we're moving. Crash the curb and it's crashed. And let's avoid not crashing it. Crashed. But the crash, the sign is not perfectly in the same. Let me just adjust its initial position a little bit. Okay. I guess that's it. That's where it is. We need to change it. Put it a little bit to the left. Let me just crash. See what I. Okay, that's better. Let me see. We crash a car, crash a dog. Okay, that's better, but not good enough. Let me just put something like an 8 and run it again. Crash it. Oh, too much. Too much. Let me put 6. Probably will be better. A better value. Crash it. Crash it. Okay, looks better. Crash. Hit the dog. Okay. Okay, restart it. Okay, thank you very much. I hope you enjoyed. That's the end of it. Thank you.